everybody was able to log into MakeCode, right? Just with your Wabash account, right? Should have been pretty straightforward. Okay, good. So that's good because it'll keep your stuff saved here, and this is actually a feature that they added since last year. So last year there was no save, or well, there was a save feature, but it was everything was stored in cookies in your browser. And so like if you went to a different computer, like your stuff wasn't there. So that really sucked. So anyway. Okay, so let's get to it. So since y'all basically haven't done anything, what we're going to do kind of for the first little bit of the class is go through a couple of these skill map / tutorial things, and we'll just go through one together today. And so this is the beginner one that says start here, right? And so let's just start here at the top, right? All right, so this will just kind of give us an overview of the of how this works. And the tutorials that are built in have instructions over here on the left, and then if we click this guy, then this will show us like a preview of the code when we run it. So anyway, a lot of this is going to be overly simplistic, but so we'll just burn through it real quick. Yeah, I know that as men, we are genetically predisposed to not read instructions, right? So the second you buy something and there's an instruction manual, what happens to that? Yeah, it goes straight into the trash, right? So, huh? You look at the pictures. You watch a million YouTube videos for how to do it, right? And yeah, because you know what didn't exist when I was back in my day? YouTube. Well, technology. Thanks. Yeah, we had to walk uphill both ways to school in the snow, fighting off rabid pterodactyls, and we didn't have shoes, and we liked it. Yeah, so yeah, it was great. Math, algebra hadn't been discovered yet. Yeah. So, okay. So, anyway, so this is all pretty straightforward. The terminology here is most of what you're going to do is in the workspace, which is this big area over here, and there's only one workspace. Um, so, what can happen as your program gets kind of cluttered or complex is that there'll be lots of stuff in the workspace, and keeping it organized can start to become a little bit of a challenge. And that's at the point where you'll kind of say, I think I'm ready to move from block-based coding to text-based coding, where it's a lot easier to keep track of large amounts of stuff. Okay, fine. Now, this is in contrast with, when I was talking about these block languages, did anybody say that they had used Scratch before, like in school? No, nobody had. Um, okay, the reason I bring that one up is in Scratch, you actually have multiple workspaces. Every object gets its own workspace, which makes it easier um, to keep stuff organized, but then has other downsides too. So anyway, um, okay, so the the first block here is this Onstart block, okay, and anything that's inside that will execute when the program starts, and that's it. Okay, it won't repeat or do anything like that unless you explicitly add an instruction to do that. Okay, so right now it's got this splash block and it says these blocks are in your workspace. Okay, and when you run it, that puts it in this like text box, and you have to hit A for the program to continue from that point forward. Okay, so think of I mean, you guys probably most of you played Pokemon of some flavor on uh, like on a Game Boy or Game Boy Advanced or Game Boy Color. How many of you guys had Game Boys when you were kids? Who did not have a Game Boy? Oh, what did you guys play on then? DS, okay. Ah, old school. Yeah. Key, what'd you have? Okay. Yeah. Well, anyway, so but DS, basically same thing, right? Just a, handheld thing. But, in a lot of games, right, you have to hit a button to advance through the text, and you can do that here with this splash block. Okay, so nothing particularly special. Um, and you can obviously change the text that's in there if you want. And if you hit the plus here, you can add stuff. Okay, and um, rerun it, and then, okay, you get more stuff. Yay. Not particularly exciting, I realize, but that's okay. Okay, so the blocks, the way that so like, let's say I wanted to make another splash thing. Uh, I just drag and plop it where I want it, and I can rearrange it, obviously, and the order therefore matters. So things are executed in a vertical order. So it starts at the top and then it'll continue at the bottom or continue to the bottom until there's nothing left to be done. Um, and you just basically drag and drop stuff. You can right click on stuff and duplicate or add comments or delete. Um, the duplication will be handy at various points. Adding a comment is nice. So I can say, something like this block makes text appear. Um, and then you can see that there's a comment there. So commenting code um, is important for really multiple reasons. Um, it's it's hard to okay. So I think last time we were talking about like that the game development process or the programming process was a lot like the um, the process of writing a good paper, right? That you do it iteratively. You start with kind of a quick draft that just gets something running, then you tweak it, then you add stuff, then you tweak some more, and then you do the final spit and shine at the end where you're double checking for semicolons and split infinitives and all of that, kind of nitty gritty work. Um, so this is something that I guess in the paper writing process, um, like how many of you guys when you're writing a paper you leave little comments and notes to yourself like add a paragraph about blah here or put this figure here or use track changes or something. Does anybody do that? Yeah, to kind of do stuff that you're not actually going to show the finished as the finished product, but it's going to be there kind of to aid you as you're working through it. Yeah, maybe. Okay, so anyway, comments are something that you'd want to do in your programming. Uh, and the one distinction though is that when you turn in your code, right, you're going to turn it in both the whole thing, which means any of the comments will also be there. Okay, and those are really handy when you're trying to read somebody else's code because if you just look at the code, um, you may not be able to just immediately know what it's going to be doing or how it's going to be doing it when you just see a block of stuff. Now, with MakeCode, because it's very graphical and color coordinated and stuff like that, like, it's pretty easy to quickly kind of decipher what's going on in the code. But if there's no comments, that can be really make it challenging for somebody who's reading your code, aka me, um, to figure out what the heck you're up to. Okay. Um, Again, not as critical with a block-based language, but is anybody interested in taking further computer science classes after this? Yeah. Okay. So getting in this habit now will serve you down the line. Okay. Um, because when you're doing more complicated programming languages or stuff where it is not at all obvious just looking at the code what it's doing, uh, getting in the habit of commenting now will pay dividends later. Okay, so just do it. Now, there is such a thing as over commenting, right? Like, did I really need to comment this particular block? No, it's pretty obvious what it's doing. But yeah, okay. So now in the game, so MakeCode here is designed around game play, and so most of the blocks that we have available to us are going to be things related to putting objects on screen, moving them around, controlling how they look, and how the screen looks. Okay, so for example, we could set the background color to whatever, and I can say, well, what background color do we want? These are our choices. Okay, so that's 16 colors is what you've got available, and that's it. Okay, so I'll pick this sort of dark blue color just for sake of example. Doesn't really matter, obviously. Okay, so you see how the first block this showed up with nothing in it? That's because this first splash block has nothing in it. So you can only advance from one splash block to the next after you've hit the A key, which is mapped to the space bar on your keyboards instead of like the A button. So they get executed sequentially, which I suppose makes sense. Okay. And of course, you can change the background color multiple times during the program, right? That would make sense. So, like in a Pokemon style game, you've got different backgrounds for different, like when you're in a battle versus when you're in town or whatever. I haven't actually played any much Pokemon, so I'm just drawing on what I've heard about Pokemon. Did you all play Pokemon when you were kids? Yeah. Okay. I'm too old for Pokemon. It came out when I was in high school, so it was yeah. Okay, so now let's talk about sprites. So let me get rid of this splash stuff because there's for now. So I'm going to set a sprite here. So a sprite is an object in the game, and the object can have art associated with it. It can have data associated with it, and one of the pieces of data that can be associated is what category it falls into. Okay, so if I'm going to create a player character, well, I'll have a player category. And in this case, there'll probably be only one thing in the player category, just the player. Okay. But if I had an enemies category, then there's going to be lots of different things that may appear in that category, right? So, I could have 15 different types of enemies, but they're all still enemies. Okay. Okay. Now, if I were to run this right now, what would appear on the screen is nothing. Okay. The sprite is there, but we can't see it because I haven't defined any art to be associated with it. Okay. And the way I'm going to add the art is I have to plop something in this image box, or if I click that little image box, then I have a couple of options for creating it. I can define its size, and 16 by 16 is the default. That's in terms of pixels, right? So these are real low res, pixely kind of graphics. Again, you have the 16 colors to work with, along with transparent, so that you can make things, you know, where you can see through part of the object. Not relevant for all objects, but you only have colors 0 through 15. That's it. So 16 total. And it is possible to redefine what those 16 colors are, but for the most part, we'll just leave it as is. It's not worth the trouble. So that may feel a little limiting to only have 16 colors, but this is kind of the 8-bit, Nintendo style world. The original Nintendo could only display, you had a bigger range of colors, but you could only display a certain amount of them at a time, right? So you did have some limitations in what you could do. And the other benefit of this sort of limited color palette is in terms of data storage. So if I wanted to, like, let's say that I just plopped down a bunch of colors in this sprite, how much data does it take for me to encode that pink square? Okay, so fair question, right? How is data encoded? Do you guys, so, uh, well, I guess we should just kind of start from the beginning, right? Um, if I wanted to have a full range of colors, okay, so millions of them, what I would have to specify is a number for how much red, a number for how much green, and a number for how much blue is going to be in that pixel. Okay. So then in the screen, right? So my monitor here, right, is basically 2000 by 1000 pixels. It's 1920 by 1080. Um, and every pixel is really a group of three things: a little red light, a little green light, and a little blue light. And if I turn on the red one at full power and turn off the green and the blue one, then what do I see in that little dot? I see a tiny little dot of red, okay? And then by mixing the intensities of each of those three colors, I can reproduce, pretty much any color under the rainbow, including grays, whites, and blacks. So gray and white you get by having all three colors turned on at the same intensity. And the brighter they are, if they're at full brightness, that's basically white. If they're all at very, very low brightness, but all the same, then you get sort of darker grays, and then there's sort of a ramp in between. Um, so if I wanted to store this pixel in having the ability to have 256 different shades of red, green, and blue, and then every combination of them, that would take 256. Well, how many? Do you guys know what a bit is, or a byte? No. Yeah. Okay. So a bit can either be a 0 or a 1. It's the smallest amount of data that you can have, right? And in terms of computers, right, electrically, this is represented by the fact that there can be a switch can be open or closed, right? Open would be a 0, 1 would be a 1. Okay, so it's either on or off. That's it. Okay, so it a bit can encode two different patterns, right? It's either a 0 or a 1. So how many different patterns can 2 bits encode? So let me rephrase the question. If you flip one coin, how many possible outcomes are there? If you flip two coins, how many possible outcomes are there? 4, right? Heads, heads, tails, 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 heads, and heads, tails, right? 4 potential outcomes. And so bits work exactly the same way. If you have 2 bits, you can encode 4 different patterns: 0, 0, 1, 0, 0, 1, and 1, 1. Okay. So that gets you 4 things. So if you want to encode 256 things, it takes 8 bits to do that. Okay, and you can. How do I know that it's 8? So what about if I asked you to flip 3 coins? How many possibilities are there? Okay, do you have to sit down and write out heads, 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 tails, 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 and kind of enumerate all of them and then count up how many there are? Or can you know how many there are before you even sit down to do this? So how did we get from 2 to 4? Like if I flip one coin, there's 2 possibilities, right? If I flip 2 coins, there's 4 possibilities. How do I turn a 2 into a 4? I can either add 2 or multiply by 2. Okay. Now in this case, it's going to be multiplying, right? So for example, let me change the example. Let's say that I ask you to flip one coin and roll one 6-sided die. How many possibilities are there for the coin? 2. How many possibilities are there for the die? 6. How many total outcomes are there? Okay, why is it 12? You multiply them because they're independent events. The outcome of the coin flip does not affect in any way the outcome of the dice roll, and vice versa. Okay, so similarly, if you have multiple coins, every coin you add just doubles the number of possibilities. Okay, and that makes sense because let's say that you flip, some number of coins and there are 5 billion possibilities. If you flip another coin, that other coin has 2 possibilities. So now you have 5 billion where that last coin is a heads, and the other 5 billion where the last coin is a tails. Okay, so it just multiplies. Okay, so if I have 8 coins or 8 bits, there's going to be 2 times 2 times 2 times 2. How many times do I multiply by 2? 8, because there's 8 coins. Okay, so this is the code for exponentiation, right? When you do repeated multiplication. So what's 2 to the 8th? It's 256, right? 2, 4, 8, 16, 32, 64, 128, 256. We? Okay, so it would take 8 bits to encode just the red. Similarly, it would take another 8 for the green and the blue. Okay, so that is 24 bits to store one single pixel. Okay, now, what is 8 bits worth of stuff? Do you guys know what the other name for this? Okay, 8 bits is called a byte, B-Y-T-E, because that looks cooler when you write it than B-I-T-E. Okay, so 8 bits forms a byte. So to encode 3 different color values, we need 3 bytes worth of data. Okay, now let's take my screen here. Okay, and in fact, let me go to, I'm going to use a little calculator here for sake of demonstration. Okay, how many pixels are on my screen? Yeah, so it's 1920 by 1080. Okay, so if I have 1920 by 1080, then that is 2 million and some chump change. Okay, but basically 2 million pixels. If each of those takes a byte, or 3 bytes actually, then I'd have to multiply this by 3, and then the unit here is bytes. And what I want to show you guys is just how much data this actually is. Okay, so this many bytes is 6 and some change megabytes. Is that a lot of data or not a lot of data? Well, how much storage do you guys all have on your iPhones? 128 gigabytes? Yeah, that sound about right? Okay, so how many is a gigabyte? Well, it depends on who you ask on that one. So yeah, how many bytes are in what's the order of things? If I have 1,000 bytes, then what is that called? A kilobyte, right? Because what does kilo mean in the metric system? 1,000, okay? And then what would be 1,000 of those? A megabyte. What would be 1,000 of those? A gigabyte. What would be 1,000 of those? Terabyte. What would be 1,000 of those? Anybody know? It's a petabyte, but nobody has that much storage yet. So, okay. So it would take 6 megabytes to encode an image that would be displayed on my monitor here. Okay. The original 8-bit Nintendo, how much memory did it have? It had 8 kilobytes of RAM. In fact, its address space, the number of addresses that like mailboxes it could do, was 64K. kilobytes, right? So we got a problem. If we're going to try and cram 6 megabytes, we could not do this on this old school hardware. It's just too much data. Okay, so one of the things that old school like the Nintendo did was, rather than encoding exactly how much red, green, and blue for every pixel was, you did a paint by numbers scheme. You said, okay, there are going to be 16 colors, and what I'll paint in this box, or the number I'll assign to it, is which one of those 16 colors it is. Okay, how many bits does it take to encode 16 patterns, 16 possibilities? How many coins would you need to flip? 4. Okay, so we could store what color this pixel is going to be with 4 bits only, if we do this using a color palette. Okay, so we would have to define over here someplace, okay, color number 0 is transparent, color number 1 is white, color number 2 is red, and so on. Okay, and then when we define our images, we say, okay, this pixel is color number 2, and that pixel is color number 5, or whatever, right? So essentially, your art becomes a paint by numbers kind of scheme, instead of storing explicitly the red, green, and blue values. Okay, so if I have here this 16 by 16 image, right, if I were to do it with full red, green, and blue, it would take almost a kilobyte, okay? Whereas if I do this paint by number scheme, how many bits does it take? It only takes 4 bits per pixel, 128 bytes. That's not a lot of data, right? If you opened up a Word file and put nothing in it and saved it, that file is going to be more than 128 bytes, right? Which is kind of ridiculous, but yeah. Okay, so that's the advantage of this sort of very limited color palette. Now, one of the annoying things about this, though, is it means that you can't just copy, like you find some really cool image out on Google image search, you can't just plop it in here, because you have to translate it into that paint by number scheme. Okay, now you can make all the assets you want by, basically coloring grids here, and there's some nice tools, so you can do like lines and whatnot. But there's a lot of stuff that's built into MakeCode that you can use basically freely. Okay, now some of this stuff, you've got, like this sword wielding hero, kind of for Zelda-y sort of stuff, and there's a princess, and there's these ghosts, and then there's some animals and fishes and computers, and this football dude, and a bat, and a monkey, and a snake, and some trees, so you can make some decorations. And, there's a whole bunch more of these things in here. Things that you could use for effects. Gee, I couldn't imagine where this was inspired by. Yeah, looks kind of Pokemon-y. You can imagine building worlds, with like ladders and buttons and clouds and stuff, and different things. So that's what's basically built in. And most of these are either 8 by 8 or 16 by 16. And you can, so like, let's just take, and you can tell the difference usually. So like, what's the difference between this hamburger and that hamburger? Yeah, this hamburger has more pixels than that one, which means that it can be a little bit more detailed in how it looks. All right, so let me just, for the sake of example, I'll pick that hamburger, which is 16 by 16. Okay, and you can see that the squares that have the gray and white checker, those are the transparent ones. So we would be able to see through those pixels to whatever is behind this object. Okay. All right, so now I've made my player a hamburger. Okay, and there it appeared on the screen. Okay, great. Well, now what? This thing also has to have a name. The default is My Sprite. but of course you can change it to whatever you want. Okay. Um, and you can have as many sprites on screen as you want, although if you put like hundreds of them, the game is really going to slow down. So obviously don't do that. Okay. On the original Nintendo, just for sake of comparison, you could have 64 sprites on the screen at a time. But there was a limitation that only 8 of them could appear on any horizontal scan line. Okay, so what do I mean by scan line? Um, in 20 years, it's going to be really hard to explain this. Um, so when you guys were kids, you probably at your house had an old tube TV, that was a billion pounds and impossible to move, right? Because it stuck out real far backwards. Okay. So how do those draw images to the screen? So, what makes a tube TV basically a tube TV? How did they work? There was, in fact, a tube. Yes. Okay. And what did this tube do? Made TV. Okay. Great, Colin. Oh, like a projector? Um, Not for TVs, no. Projectors would do something like that, yes. But the TV, so what the tube was basically a giant electron gun. Okay. And so it would uh, generate electrons and then using uh, carefully tuned magnetic fields, accelerate them all towards the screen. Okay. And by adjusting that magnetic field, you could adjust where on the screen they were going to hit. And so what the thing did was it scanned from left to right, starting at the top. So it would go on, across, turn off, come back to the beginning, on, go across, and so on. And it would do that very, very, very quickly, obviously. And so you wouldn't be able to see it, but essentially it'd be like if you slowed, like did it in slow motion, you would see bzz, 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 and so on, okay, from the top of the screen to the bottom of the screen. And then it would go back up and restart on the top. And if your image was static, then you wouldn't notice any difference. But if you were watching a movie or TV or something where the image is going to change 30 times a second or so, then you would be able to see the motion without seeing it doing the scanning thing. Okay. Um, so a scan line is one of those horizontal beam strokes. And now nowadays, digital screens don't use that, because they work fundamentally differently. But the original Nintendo, when it came out, LCD screens, I mean, they existed, but they were incredibly expensive. Um, and so the Nintendo, right, was designed. How did basically everybody hook that up? They hooked it up to a TV. And in fact, in the old computer days, so you could buy a monitor, which was basically just a fancy TV, um, but they were really expensive. And so most people in the 80s, when they bought a home computer, they hooked it up to a television rather than to a dedicated monitor because they already had a television, and that was sort of good enough. Okay. And then same thing with the Nintendo, right? Um, so now, how did you hook the Nintendo up to the TV? Do you guys remember this? Yeah. So back in my day, you had to hook it up to the cable input, right? And then tune the channel to channel three and or tune the TV to channel three and then turn on the Nintendo. And there was a little box that went between the cable and the TV called an RF modulator. No? Do you guys remember that? You kids these days. Yes, okay, that obviously was later. Red, white, and yellow hadn't been invented when I was a kid. Actually, it had, but huh. No, my entire childhood was black and white, and then suddenly the world turned into color. It was amazing. Yeah, yeah, exactly. just like in Wizard of Oz. So, yeah. Okay, so right. So this paint by numbers thing is what allows us to store these images without taking up gargantuan amounts of data. Okay. Now, maybe this gives you just the briefest of taste why, if you guys download, well, like what games are you playing nowadays on your phones or consoles or whatever? Huh? Get out. If you're playing Fortnite, getting out. Okay. Rocket League. Okay. How big is Rocket League? Yeah, gigabytes worth of data. Yeah. So pretty big, right? Gigabytes. The original 8-bit Nintendo, think about it. That when you grabbed a cartridge, right? That cartridge had 40 kilobytes of memory on it. 32K for the program and 8K for all the images. That's it. Right. And now Fortnite is, or Rocket League or whatever. Or is anybody playing Elden Ring? Yeah. If you've gotten addicted yet? Yeah. Okay. Well, you're making it to class, so that's a good thing. You're not staying up too late playing Elden Ring. And, huh? Is your roommate Balake? No? Oh. So, yeah. So the reason that games are so big is because of all of that art storage, right? The games you're playing nowadays have 3D animated characters and all kinds of really fancy graphics, and that all takes data to store. They have audio, um, high quality audio. Um, basically, the old Nintendo was capable of making beeps and boops, and that's about it, right? Okay, so let's continue here. Um, and we picked our hamburger. Okay, great. And now, if I run this game, can I move the thing? Nope. And if I hit space or A or B, what happens? Absolutely nothing because I haven't told it to do anything yet. Okay. So, for example, let me choose here under the controller on a button pressed. Okay. And now this is an example of a block that doesn't attach inside other blocks. Okay. So this is its own sort of object and things go inside of it. So now this makes sense. I only want what's inside of this to trigger whenever I hit the A button. Okay, so what do I want to have happen when I hit the A button? Well, there's a whole lot of things I could do, right? In this example, it says start spray effect. Okay, so we'll do, let's see, where is that? Did I just miss it? Yeah, here it is. Okay. So I'm going to have the spray effect. And so now if I run it and I hit the button, okay, then it's going to do this sort of effect. Now, it doesn't stop because I also never told it when to stop. Okay, so I could actually, if I duplicate this and I say on a button released, I could, under sprites, oh, well, or I could do this probably easier, is let's just tell it, hey, I only want to do it for half a second. Right, and that way it doesn't keep going on forever. Right? Okay, now obviously you could put as much as stuff as you wanted here, but that's good enough for now. Okay, great. Now, programming, like, a lot of games use random number generators, right? Because otherwise it'd be the same every single time. I could make this amount a random number between, say, what does it say to do? 100 and 600, and those are in milliseconds. So this would be, a tenth of a second to just over half a second. right, to give it some variety. Okay, great. But what this also demonstrates is sort of how data works. So most of the most of the little things here where you could type in numbers or select things are kind of these roundy sockets, and uh, you can plop a roundy socket item into a roundy socket and build up more compound expressions by doing so. Okay, in math or something, this would be like putting things in sets of parentheses. Like, say for example, I tell you f of x is x squared, and then ask you what's f of 3. What do? How do you compute it? You just replace the x with the 3 and then calculate, right? So you can have compound expressions and I could plop another thing in here. So for example, I could say pick a random number from a random number to a random number. That's maybe a little bit silly, but okay. So what's this going to end up doing is it's going to pick something between 0 and 1,000, but it's going to pick it by first picking the low end, then picking the high end, and then picking something out of that range. Okay. Now, like I said, this is maybe a silly example, but right, the point of it is that you can stack these things basically as much as you want. Now, it may be a little bit hard to see on the screen here. It's a little easy on your computer, but these things do have a very thin black outline, so you can kind of see how they're nested. It doesn't show up particularly great on the projector, especially with this purple, but you get the idea. Not rocket science. We okay. Um, and if it is rocket science, got your man right there. Okay, so great. So we just finished that tutorial. Wonderful. All right, so now there's a whole bunch more of these, and a lot of them, like I said, they're pretty easy. Okay, and so let's just look at some of the other ones that we've got here. Oh, question? Yeah.
So if you wanted to move like your character, would you have to program each like if you want to go up, you have to program that because
There's two options, yes. So let's actually just do that real quick.
when I tried doing it, I put up, make it like move, but it allowed me to move it anywhere instead.
Yeah, okay. So, all right, let me actually get out of this. So, in the tutorials, you'll notice that the number of blocks you have available is limited, and they do that deliberately so that you're only given the blocks that you need. But let me go back to, um, oops, sorry, I think I clicked the wrong thing. This is the one I wanted. Okay, sorry. Okay, so under controller, I've got two options. I can say move my sprite with buttons, okay? And what that allows me to do is then I can move it in any direction, right? But if I get rid of that and I use controller and I say something like on, up, pressed, what should I do? Okay, this is going to drive you guys crazy. Okay, so every time I hit up, it's moving up by 1 pixel, but if I hit down, nothing happens because I would have to make a corresponding one of these for down, left, and right. Okay, does that make sense? Whereas if I do use the move with buttons, then what that does is I can say, all right, what's the velocity it should go horizontally and what's the velocity it should go vertically. And it's also a lot smoother, right? So most of the time we'll use this one just because it works better, but there are situations where this other view is good. Okay, now two things, and this is why did I say that's going to drive you crazy when I made this?
We need to do it for each one.
Well, okay, yeah, you need to do it for each of the arrow keys. right? So I'd have to make a similar sort of block for left, right, and down. Okay, what else about just this one is going to drive you crazy? Why is it -1 and not 1? Because which direction was my object supposed to go when I hit the button? It went up with a negative. Wait a minute. Does that make sense? That's making everybody from math class scream, right? Because in math, what's your coordinate system? You've got the origin someplace, okay? And if you go to the right, the x values are increasing. And if you go up, the y values increase. That's not the coordinate system in computer graphics, okay? Just to keep everybody on their toes. Now, what is the coordinate system? It's irritating, but it also makes a whole lot of sense. Okay, so where should the origin be? Where's 0, 0? Well, on our screen here, what are maybe logical choices for where it could be? Bottom left, top right, bottom right, or dead middle, right? Those would be the 5 logical choices. Where is it? It's at the top left. Okay, now think about why this made sense back in the day. Right? How did you draw an image to the screen? You basically scanned across the same way that you read a book, right? First line, left to right, second line, left to right, and so on, okay? So if you wanted to like take a book and make a coordinate system for it, wouldn't it make sense to say, all right, which line are you on and which letter are you on going from left to right? That'd be very logical, right? Okay, but what does that mean about the y values? The line that you're on. When are you on a new line? When you go down, the line numbers increase. Does that drive any of you crazy? No, it's just the way it is, right? It drives you crazy. Okay, well, I got bad news for you. The world is a crazy place. Okay, if you haven't noticed already. Um, huh? And that is a perfectly acceptable pizza topping. There is absolutely nothing wrong with pineapple on pizza. In fact, it's delicious. Yeah. You put like a barbecue base and then the cheese, and then you get put ham or Canadian bacon and pineapples and jalapenos. And that, sir, is a good pizza.
Okay, so my problem with what you just said is that you said the origin's in the top left,
Hmm.
but really it's rotated because going down is positive y.
Hmm.
So
So it's not actually rotated, right? Um,
because the x way, because the x is
the x positive goes to the right still. Okay, if it were rotated like what you're thinking, no, it's not reflected. It's left-handed. Okay, so positive x goes this way, positive y goes that way. Now in math, it goes like this, right? You can't rotate, huh? Yeah. Okay. But the way we say this, right, is this is a right-handed coordinate system, whereas this one is a left-handed coordinate system. Okay, now, and has anybody taken physics? Right, so you guys know, are you in physics now? No. Did you ever use the right-hand rule? Okay. Um, and there's a reason that we use the right-hand rule. It's because the math coordinate system is set up in a right-handed kind of way. Okay, now, um, this one is sort of opposite of that, so we call it left-handed. Now, it's very logical if you think about the way the screen is laid out, right? It makes sense to draw it that way. Um, and early computers, you could almost think of their displays as being like typewriter or printer output, right? You printed um, from the top going down, and then it fed out the end, right? So yeah, that's the coordinate system, and that's why if I want to move this object up on the screen, I'm actually decreasing its y value rather than increasing it. Okay, it's irritating, I know. You'll get used to it. In 2 weeks, you won't even think about it. You'll just do it. Okay. Now, what this does mean, though, and this is why it does drive me crazy, is because what am I doing? half of my day I'm teaching computing where it's this, and then the other half of my day I'm teaching math where it's this, and I have to not screw them up and get them mixed up. Okay, but also, let's say that I was trying to program something like where I needed to know, um, like I needed to do some math to figure out where things are going to be. Well, if I'm going to sit down and do the math on paper, I'm going to do it with the math coordinate system. But then I have to remember when I finish all my work that the y values are all flipped and not screw it up. Okay. Now, this makes it real fun when 3D graphics get involved. Now, MakeCode obviously doesn't do that. It's just 2D. But where is the z-axis? It comes out of the screen towards you, and the positive z-axis is towards you. Okay. Which is weird because you probably think of the z-axis as being up and the xy axis being kind of the floor, right? But that's not the way it's done in computer graphics. Yeah. Anyway. Okay. So in terms of moving the thing, it's in terms of the game, much better to have this. Okay. Now, let's say, for example, I don't want my sprite to be able to move left and right. If I set this to 0, then even if I hit left and right, it's not going to move because it's moving with 0 velocity. Okay. And what would be a game where you might want your player to only be able to move vertically but not horizontally? Flappy Bird's a good one, right? Because you can move up and down. Now, I think Flappy Bird's a little different because you hit a button and he kind of like bounces a little bit, so it's not perfectly this. But if you were doing like a space shooter like Galaga or something, where you're you're sort of scrolling through the world from left to right, all you can do is move up and down and shoot. In fact, we'll make a Galaga style game uh, as one of our first things. Okay, so good question. Any other questions on things while we're at it? No. Okay, so let's look at some of these other ones. Okay, so the clicker game. This one's stupid. Has anybody played Cookie Clickers? Yeah, or know what Cookie Clickers is? You think so? All right. Well, in school to get, yeah, because they blocked it probably from,
that and like people would do it and just get unlimited like clicks on it.
right. So this is Cookie Clicker, right? If I click the cookie, I get cookies. Okay. But then I can spend my cookies on a cursor that sits there and automatically clicks the cookie, and I get zero point 0.1 cookies per second. And if I keep clicking, right? So this is the game you played when you were in high school and bored out of your mind, right? We didn't have things like this. We just slept when we were in high school. Uh, and so I can get more of these. And I don't know why it's being so slow. Um, and then as I get more and more cookies, I can unlock and purchase grandmas who make cookies, and they make cookies faster than the clickers work. And then if I want to get even faster, then I can buy cookie mines or farms, sorry, where I farm cookies because it totally works that way, right? Yeah. So this is the one of the world's stupidest games, but hey. Okay, so let me close that. So if I wanted to make a sort of version of that, right, then um, let's see, scene, set background image to my assets, and we'll do this one, okay? All right, so then we'll add our splash. Okay, wonderful. All right, and then our controller on A button pressed. Info, change score by 1. Okay, so what's going to happen? Right, every time I mash A, I get a point. Okay, stupid, yes. Now, the score here displays at the top right of the screen. That's actually sort of a defaulted thing into MakeCode. You can change sort of how some stuff gets displayed, but score by default is always at the top right. And then if you made player health, that would get displayed at the top left. There are ways to change that, okay? All right, so what else did it suggest to do here? It said to say start a countdown, okay, and of 10 seconds. Oops, that's not what I meant to do. Okay, so this countdown thing then allows me to, right, the countdown timer you see is up there at the top, and then what's the goal? Right, it ends the game when I get when 10 seconds has expired. Okay, wonderful. All right, so that's done for that tutorial. All right, let's go on to the next one, right? So here, well, wouldn't it be nice to actually have a button that actually looks like it clicks every time instead of the score just going up? Yeah. Okay, so how are we going to do that? Well, we have all the code that we had before, okay, but we're going to create a sprite here, and so we'll do set my sprite to a sprite of kind whatever, okay, and we're going to pick here in my assets, they already have some stuff, so we'll pick the A button that's in the up position, okay, and what we want to do now is make it so that every time I hit the A button, what happens to the art? It switches to the down version, okay, and then switches back, right? Because if I switch it to the down version and I just leave it there, well, then it's going to look like the button's permanently mashed. So I don't want to do that, okay? And on A button press, so I'm going to set sprite image to, and then pick the A button that's down, okay? And then now we have to figure out how to get it back up, okay? So let's just test it, right? And it's stuck right now. All right, so how do I get it back up? Yeah, I got to rechange the image back, okay? So this thing is, okay, so oops, that's not what I wanted. On countdown end, so when the countdown finishes, I can trigger the game over, but I'll make it win. And the difference between win and lose is, let me just show you. Okay, so when it loses, or sorry, when the timeline ends, right, you see how it's got the confetti instead of kind of making the screen melt? All right, so great. So you can have game over, and then if you hit this plus, you can actually select what you want the effect to be. So I'll just leave it as confetti, but which is the default. Okay. All right. So we also need to change the art. Okay, which is actually in the next tutorial. Actually, no. Did we miss it? Yeah, we did. Okay. All right. So where should I put the change image? So what would happen if I put it right here. All right, so let's try that. Okay, is it changing? It doesn't look like it, but it is. Okay, why doesn't it look like it? So fast that you can't see it. Okay, so that's not what we want to do. What we could do instead is say on a button released, move it up. Okay, and here, right, now it actually looks good. Okay, good. And now the other thing here is this action only gets triggered when the A button is pressed, but there's a third option here, which is repeat. Okay, so let's see what happens if I change it to repeat. So look at what's happening to my score. Right? Now you guys can't see my finger, but I've got it just holding the space bar down. Okay. Whereas if I make this on pressed, then once it's pressed, I have to release it to then press it again. Okay. Now, do both situations make sense to be able to have in gameplay, where you can hold a button or where you have to like literally press it one at a time? Yeah, like what would be game examples where we might use either one? For the clicker game, we probably want the press and release version. Where would it be good to have the holding? Okay, yeah, jetpack kind of thing where when you hold the button, the jetpack's active, and when you let off, it turns off. Okay. Any others ideas? Oh, like something where you charge up kind of thing. Yeah. Okay. So like, how many of you guys played Mega Man or any of those games? uh, where eventually you get the ability to do exactly that. Where if you hold the fire button for 5 seconds, it'll charge up a shot and then you can release it. Um, yeah, so plenty of situations where you might want one of those. Okay, good. All right, so we're done with that guy. And then here, this one's kind of stupid because all we're going to do is spray projectiles. Okay. And let's see, spray projectiles on pressed here. Okay, so projectiles are something that we're going to use quite a bit for various different reasons. Okay, um, and we're going to do two things. We're going to change the asset here to this star. Okay, whatever. Um, and then if I, so the things I need to specify with the projectile is what does it look like, how fast does it move in any direction, and where does it start from? Okay. For the most part, you want to start at your player's location. Or let's say in the case of enemies that are shooting back at you or something, you'd have it start at that enemy's location. Okay, fine. Um, and if I run this now, okay, why are they all moving that way? Yeah. So, and what velocities did I specify here? 50-50 was the default. Okay, but how much is that is in the x direction? 50. So that means I'm going to the right, and 50 in the y means I'm going down. Okay. Now, obviously, do I want 50 and 50 here? Probably not. Okay. And so what do we want to do? Let's change these to be randomized. Okay. And what randoms do we want? Well, let's randomize both the x and the y velocity. What would be a reasonable range for the x's? It's not a degree. Yeah, so it's not like an angle. We, yeah, something like negative 100 to 100. Now, why do the negatives make sense in addition to the positives? Yeah, because would it make sense here for the star to be able to go both left and right? Okay, so I'll do negative 100 to 100. Um, if I did something with an angle like you suggested, we could actually do that. But then um, I have to specify the horizontal and vertical velocity. Okay, so in fact, let me just come over here. If you gave me the angle, right, how do I get the horizontal and vertical velocity out of that? Yeah, trig, right? I'd have to say, okay, the x is going to be related to the cosine or proportional to the cosine of the angle, and the y would be proportional to the actually the negative sign of the angle because the coordinate system's flipped. But I'd have to do that trigonometry basically. Um, no, there's no polar coordinates. Um, it's all Cartesian, okay, and that makes sense because that screen is an inherently Cartesian object, right? It's arranged as a grid of pixels. It's not like a radar scope or something, right? Um, yeah. So if you want to do things in polar coordinates, which would be specifying angles and distances, then if only there were a way to convert from polar to Cartesian coordinates. If only there were some equations that could do that for you. And actually, that's not so horrible because that's the easy direction going from polar to Cartesian. What's the pain in the butt direction? Because you have to do that arctangent thing and then worry about what quadrant and yada yada. Okay. Um, and actually, there is a nice function built in here that allows you to do that more easily than you might think. Now, how many of you guys have seen polar coordinates like in trig in high school? Maybe, yeah. And actually, on the subject, who is in a math class now? What math classes are you guys in? So I know 110, 111. What do you? Okay, 331. You did Calc 2. What have you done? Calc 1. Okay, nothing. No. Ah, okay. Gonna do more math. But you certainly all took math in high school, right? You may have regretted it, but whatever. Okay, so our horizontal velocity negative 100 to 100 at random makes sense. What about our y's? What makes sense here? All right, now if we make it the same, then some stars could go down, right? Are we okay with that? That's a game design decision. Okay, so is there any reason that it has to be negative 100 to 100 from a programming standpoint? No. This is now at the point where you're deciding how do you want it to look, right? And if you want it to look this way, great. If you don't, that's also fine, right? So this would be a decision that where you're having to think of the aesthetics of how do you want the thing to appear on the screen? Do you want it to go all directions or not? But that's an aesthetic, like artist sort of decision, not a programming one. Okay, good. Okay, and then we changed the values, and now we have our stupid clicker game. Yay! How exciting. Okay. Um, oops, sorry, I forgot one thing, which is how can you share um, your game? Okay, so claim my reward, great. But what I can do is, let me hit view code here. Um, when I'm in a project that's not in a tutorial, okay, so let me just go back to the main menu here and just sort of show you this part. Okay, So once I have a finished thing, if I click this button up here, I can make a shareable link, and this is how you guys turn things in, right? Canvas, right, has the option to, I can have you guys just have a little text box, and all you do is paste something into the text box. That's what you'll do. You'll publish your project. When you hit publish project, it'll give you a link. That's what you plop in on Canvas, and that's how you'll be able to share games with each other for when we do reviewing each other's work, and also turn things into me. Okay, but you've obviously got to do that step first. Okay, all right. So good, not rocket science. Yeah. All right. So we'll see you guys on Tuesday, and I'll